Good afternoon. We will continue our discussion on IC engine gas turbine, and today we will discuss about another important module of this course, that is the combustion. And finally, we will see the pressure crank angle diagram. From there, we try to estimate the pressure rise, and of course, the effect of pressure rise during the combustion process on the total work output. So, if we try to discuss about the combustion in SI and CI engines, in fact combustion in internal combustion engines, then we need to know what are the we need to briefly discuss about the chemical reaction and therefore the chemical kinetics. But again I am telling combustion itself a subject, and this is very difficult to discuss all those aspects in this particular course, but we will try to briefly touch upon the what is combustion, what do we mean by this, and what are the different issues, aspects for the combustion of the combustion of SI and CI engines. So, first we will discuss about what is the combustion, and then we will try to discuss about that combustion when occurs in SI engines, what are the different I can say issues associated with the combustion, and if the if the combustion, rather the I can say reactions are not occurring properly, or there combustion takes place in presence of the oxygen which is not sufficient, or if the combustion takes place in presence of excess oxygen, then what will be the problems. So, first we will try to see what is combustion. As I said that combustion itself a subject, so we will briefly touch upon what do we mean by that. So, if we try to recall, in fact we have studied in our 10+2 level different chemical reaction, whether it is exothermic or endothermic. So, combustion is essentially exothermic reaction, and because of this process heat energy energy is liberated in the form of heat energy, in the form of heat to be precise. So, when we supply fuel, as I said in my last lecture, that fuel is basically hydrocarbon, not a single hydrocarbon, rather a family of hydrocarbon. Now, when we supply fuel and we allow fuel to mix with oxygen, and then we compressed it, and finally we try to ignite the fuel, whether it is done using spark plug or whether the thermodynamic state of the compressed charge at the end of the compression process is used to ignite the fuel air mixture. What will happen? Ultimately the chemical energy that is remaining stored in the fuel will be converted into the another energy, that is nothing but the heat energy. So, in a brief way I can say that combustion can be considered as a relatively rapid chemical reaction of hydrogen and carbon in the fuel with the oxygen in the air resulting in the liberation of energy in the form of heat. So, this is I can say what is combustion. Rather, I have tried to explain in a simple way, so that without going into the subject, without going into the details of this course, at least we should try to understand what is the meaning of combustion. Combustion, which is nothing but the chemical reaction of what? Hydrogen and carbon, which is present in the hydrocarbon with the oxygen which is coming from the air. So, now if we try to relate the different strokes which are there for the internal combustion engine operation, that is intake, then compression, and at the end of the compression process we ignite the compressed charge or compressed air, if it is SI and CI engine respectively, to initiate the combustion. Now, what we have seen that if it is fuel, if the fuel is sprayed, fuel is supplied into the engine cylinder through the fuel injection system, that is fuel nozzle, then only air will be taken into the engine cylinder during the intake stroke. The air which is taken into the intake cylinder during the intake stroke into the engine cylinder is taken only to obtain oxygen, which is required for the burning of the fuel that is supplied, that is sprayed into the cylinder. So, that means hydrogen and carbon which is present in the fuel, that will be combusted, that will react with the oxygen present in the air, essentially to release energy in the form of heat, and that is what is combustion. Now, today we will discuss about the SI engine combustion, and again I am telling that combustion we should try to discuss briefly what do you mean by that. So, now if I next go to discuss about the SI engine combustion. For that we try to recall that for the SI engines, fuel air mixture is taken into the cylinder during intake stroke through the carburetor. The objective of carburetor is to supply, rather to ensure homogeneous mixture of fuel and air that is supplied, and also to supply a chemically correct air fuel ratio which is required for the efficient or smooth combustion. Now, the compressed charge, which is nothing but compressed air fuel mixture, is ignited to initiate combustion using spark plug. So, the formal definition of combustion, that is what we have discussed in the last slide. So, what do you mean by combustion? Combustion is, so combustion takes place, combustion initiated, that is I can say that is that can be realized by the appearance of a visible flame. So, when we talk about SI engine combustion, if we try to recall now, the compressed charge at the end of the compression stroke will be ignited using an external agent like spark plug. So, the zone, rather the compressed charge which is very nearer to the spark plug will be considered the first, rather I can say the initial zone from where combustion will start. So, that means the fuel air mixture, the compressed fuel air mixture that is there in the vicinity of the spark plug will take part in the combustion, and from there, as I said, combustion started, that means a visible flame will appear. So, the flame that will start, that will initiate in the zone very close to the spark plug will now try to heat off the surrounding charge. In this way, the entire charge which is there in the clearance volume will be combusted. Now, SI engine combustion can be, so if I try to draw a schematic, so we have SI engine cylinder, this is spark plug and so this is fuel, this is air. So, this is air plus fuel which is coming through intake manifold. We have valve and this is and it will rotate. So, this is spark plug, I am not going to label. So, what I would like to say, at the end of the compression stroke, the charge will remain compressed in the clearance volume. So, this is top dead centered, this is bottom dead centered. So, in this zone charge will be compressed. Now, a spark will be generated from the spark plug and that spark plug will try to initiate combustion in the regime very close to the, rather I can say within the compressed charge which is very close to that spark plug. So, spark which is generated by the spark plug will ignite the charge which is there in the vicinity of the spark plug. And then if I now consider this is the combustion chamber and the spark plug. So, this is basically, rather I can say, if I consider this is the combustion chamber and this is spark plug. Now, the compressed charge is there in the compressed clearance volume. So, this is the clearance volume. So, now a flame will be propagated, rather I can say a flame will be developed in the region very close to the wall, very close to the spark plug because of the combustion. So, the moment when we switch on the spark plug, the charge in the vicinity of the spark plug will be combusted because of the spark which is being developed by the spark plug. And we have discussed in detail about the production, rather development of the spark which is required to break the gap resistance between the spark, rather the spark gap. Now the flame, so that is the charge in the vicinity of the spark plug will be combusted, and as I said that combustion started, that is realized by the appearance of a visible flame. So, a flame will be developed and the flame which is being developed because of the combustion in the region very close to the spark plug, rather within the combustion within the charge in the region very close to the spark plug, the flame will now try to propagate. So, what you have understood, because of the combustion the chemical energy will be converted to the heat energy. So, the heat that the temperature will now try to heat up the temperature of the surrounding charge layer. So, the surrounding charge layer again, because of this heat energy surrounding charge layer, that heat as if now acting just like a spark for the surrounding charge layer, and that charge layer again will be combusted and will get another flame, and in this way the this flame front will travel up to the furthest distance, and in this way total charge in the combustion chamber will be combusted. So, this is what is the combustion process. Now, we will see that the SI engine combustion can be classified into two different classes. One is known as normal combustion, another is known as abnormal combustion. This abnormal combustion can be further classified into two subcategories. One is known as pre-ignition and second one is known as, that is, detonation or knocking. So, we have understood the spark plug is responsible to initiate combustion in the zone within the compressed charge which is very close to the rather in the vicinity of the spark plug, and the flame front which is produced because of the combustion, that will try to propagate the heat energy which is being generated, that will try to heat up the surrounding charge layer, and that heat is acting as a artificial spark plug to ignite the surrounding charge layer. In this way, the flame front will try to propagate, and the charge in the clearance volume will be entire charge in the clearance volume will be combusted. Now, there are two different classifications. I mean, the SI engine combustion can be considered, that is, one is the normal combustion, other one is the abnormal combustion, and this abnormal combustion can be further subclassified into two categories. One is known as pre-ignition, other one is known as the detonation or knocking. So, now we will discuss these three important, or these two important, I can say, methods, that is normal combustion and the abnormal combustions, abnormal combustion little bit more. So, if I try to discuss about normal combustion, so what is normal combustion? So, the word normal, that itself suggests that the combustion will takes place in a fairly uniform manner. So, if we try to recall, in the last slide we have discussed that the flame which is produced in the vicinity of the spark plug, the flame front will now travel from that region to the farthest areas of the combustion chamber. Now, the movement of the flame, that has I can say a significant role to play to determine the overall combustion process, whether the combustion will be smooth or combustion will be erratic. So, try to understand that the primary flame front, the main flame which is produced in the vicinity of the spark plug, will now travel, and the, as I said, the heat energy which is generated, that will be that will try to heat up the surrounding charge layer, and in doing so the entire charge will be combusted. As if entire charge will be combusted, as if the flame, so the initially flame which is produced, the energy will be transferred to the next layer, flame will be extinguished. Next layer will take part in the combustion, another flame will be produced. So, as if the main flame front is now travelling and propagating into the entire combustion chamber. So, depending upon the movement of the main flame front, we can classify whether it is normal or abnormal. In the normal combustion, the main flame front which is being developed will traverse the entire combustion chamber in a fairly uniform manner. There is no any chaotic situation, no erratic movement, and that is what is known as normal combustion. So, if I try to write that, in this type of combustion, the flame initiated by the spark travels across the combustion chamber in a fairly uniform manner. So, there is no erratic movement of the flame front which is moving, the main flame front which is moving across the combustion chamber in a fairly uniform manner. But what about the abnormal combustion? So, this is normal combustion, and next one is that is classified into two different category, pre-ignition and second one is the detonation or knocking. We will see that for the abnormal combustion, of course, it is just opposite to the normal combustion. So, the movement of the flame front, main flame front, which is being produced by the spark plug, will not have an uniform movement, rather I can say the movement will be erratic, and that is because it is called, that is because of the different issues. That is what we need to know, and rather we should try to address what are the different issues for which the movement will be erratic. So, the abnormal, so that is the movement is not normal. Now, the preignition and detonation, these two are very important. I can say terms, but we will discuss about the preignition, then we will see that because of this preignition detonation and knock occurs. So, knowing the importance of the preignition, why the preignition is occurring, and by how we can prevent the preignition of the abnormal combustion. We will see that we really cannot stop the preignition mechanism of the SI engine combustion. So, even then preignition is occurring, how we can control the detonation and knocking. So, what I said, detonation and knocking is the consequence of the preignition. Preignition, if I can stop fully, I can say that there should not be any detonation, but what I told that preignition cannot be completely stopped. Even then we should know what are the different steps we need to follow, we need to consider, we need to take into account by how we can prevent detonation and knocking, but although preignition will be there. So, I will write now the preignition, and then we will try to discuss about what is the detonation and knocking. So, what is preignition? Preignition is that, if I try to recall, rather if I try to go back my previous slide, then what we can see, the spark plug is responsible for creating spark, and that spark is responsible to ignite the fuel air, the charge which is there in the region close to the spark plug. So, we can say we require one external agent to initiate, and that is what we have seen. So, in our daily life, when we use gas stove, we use gas lighter. So, we switch on the gas stove, gas comes out, and then we just switch on the gas, just we use gas lighter to initiate combustion. So, once we initiate combustion, then we need not require gas lighter, then it will continue. Similar concept can be used to understand what is happening in the context of SI engine combustion, as if the spark plug is using just like a gas lighter. The moment it ignites, the combustion will take place automatically. Now, by how, that is what very important. So, initially spark plug is required, but what I can say, engine is continuously running. So, at a later stage of a few cycles, what will happen, the piston face, cylinder valves, intake valve, and also exhaust valves, and also the intake valves will be in a position where will be in a tempted condition. That means the temperature of these locations will be very high. So, the moment when the compression, rather the intake charge is compressed, the hot spot like piston face, cylinder valves, exhaust valve, and also the intake valve will now act like a these hot spots will now act like a artificial spark plug. So, the main flame front definitely will come from the spark plug, but there will be chances to have, I can say, secondary flame front from these locations. So, pre-ignition, that means our objective was to ignite fuel after the combustion process, after the compression process, but it may not happen because of the excessive rise in the temperature of the piston face, cylinder valves, exhaust manifold, exhaust valve, and also the intake valve to some extent. Intake valve temperature will not be very high because continuously you are taking fresh charge. So, the movement of the fresh charge through the intake valve will try to reduce the temperature, but I cannot say completely the temperature will be reduced to a level which is no way responsible for the this igniting, but this but I can say temperature will not be very low, but at the same time I can say this place is not very severe for the igniting charge acting like an artificial spark plug. So what I can say that although the compressed charge, the charge which is taken, the fresh charge which is taken during the intake stroke will be compressed, and the compressed charge will be ignited by switching on the spark plug. Instead of that, at a later stage of a few cycles, when the temperature of the piston face, cylinder wall and the exhaust valve and to some extent intake valve will be higher, the spots will act like an artificial spark plug, and another flame front might start traveling, another flame front might initiate from these locations and they start traveling across the combustion chamber. What will happen because of their travel, and that is what we should know in this class. So if we try to write what is pre-ignition, and from there we will try to discuss the consequence of the pre-ignition. So I am writing that if some of the boundaries, rather I can say a few spots like piston face, cylinder walls, exhaust valve, and also I can write the intake valve. Become overheated under certain operating condition. These spots act like an artificial spark plug and ignite the adjacent, I can write adjacent fresh combustible charge, fresh combustible charge, and I can say distinct flame front is produced from these spots, and this process is known as pre-ignition. So I have discussed, just now I have written, and that will help you to keep in mind that there will be a few spots under certain operating condition. What is a certain operating condition? When there will be different operating conditions. So I can say at a later stage of a few cycles, maybe I can say cooling is not properly done, maybe the air which is being supplied which is not adequate. So maybe the residue from the previous cycle is very high, So, maybe exhaust is not working properly. Because of many things, what will happen, the temperature of the few spots will be high, and the spots will be acting like an artificial spark plug, and it will try to ignite the adjacent fresh combustible charge, and a distinct flame front is produced from these spots, right. So, I can say this process is known as preignition. So, we have understood what is preignition. Now, the preignition, what will be the consequences of this process? So, we need to know what is the consequences. So, if I write the consequences of preignition. I am writing preignition is not a desirable phenomenon, and because of this phenomenon, the combustion process becomes both erratic and uncontrollable, right. So, this is the consequences of the preignition. We will discuss now an important consequence of this process, of this phenomenon, and that leads to the formation of knock. So, now we will try to know what do you mean by detonation or knocking. So, next we will try to discuss about detonation or knock, right. So, if I try to recall that this preignition is not a desirable phenomenon at all, combustion will be highly erratic, it will be uncontrollable. Not only that, this phenomenon will leads to another important detrimental phenomenon for the internal combustion engine operation, and that is known as detonation or knock. So, if I try to discuss that, we have understood that the primary flame front will produce from the spark plug, and each and every cycle the main flame front will proceed from the spark plug area, and it will travel across the combustion chamber, and because of this entire combustion will be completed. But what we have discussed now, that there will be a few spots, and these spots will act like an artificial spark plug, and at a later stage of a few cycles, cycles of operation, what will happen, these spots will be acting like an artificial spark plug. So, now if I try to draw the combustion chamber, and if I try to draw the top view, say the combustion chamber is basically cylinder is is cylindrical. So, combustion chamber is cylindrical. Say we have a spark plug over here, and the compressed charge which is located in the vicinity of the spark plug will be combusted because of the spark which is being produced by the spark plug, and a main flame front will proceed, rather it will proceed like this, and it will try to heat up the adjacent charge layer, and in doing so the entire combustion will be completed. But what we have discussed now, there will be a few hot spot. So, we really do not know, maybe exhaust valve is here. So, maybe exhaust valve. So, this valve, say this is exhaust valve, maybe this is intake valve, and of course, the cylinder walls. So, there will be a few hot spot which will be acting like artificial spark plug. So, another flame front also will start traveling, will produce, and they will start traveling like this. Right. So, this is the main flame front. So, this is main flame front, and say this is 1, 2, 3 and 4. So, 2, 3, 4 are the secondary flame front. Secondary flames. So, the main flame front will start traveling from point 1, that is true, and what we have seen, there will be another a few flames which are now traveling from different other points, rather different other hot points. Now, question is, if the speed or velocity of the main flame front is very high, then by the time when the other secondary flames start propagating, the main flame front will try to suppress them, then the problem of detonation may not be there. But a case may be when the speed of the main flame front is not very high. What will happen? By the time when main flame front reaches the furthest location where another flames is produced, the secondary flame will try to so secondary flame is now produced like this, and main flame also is traveling like this. What will happen? So, if the flame speed is main flame speed is not very high, then the time which is taken the main flame to reach the furthest location of the combustion chamber, by that time another flame, another secondary flame which is coming from the furthest location will try to collide with the main flame. Now, because of this collision, that is the collision between the main flame and secondary flame will try to create an audible noise, and that is what is known as detonation or knocking. So, we have understood that the hot spot, the preignition, that is what we have discussed a few minutes back. The preignition is not a desirable at all. If preignition is not there at all, then chances of detonation is not there. But it is very difficult to say, it is very difficult to ensure that the preignition should not be there. So, preignition should be there, because we cannot prevent out of the excessive heating of the piston face, cylinder walls and exhaust valve. But we need to ensure that the main flame front propagation should be controlled such that the secondary flame won't get enough time to propagate, and the time by which secondary flame will be will be in a position to propagate, by that time main flame will try to reach there, main flame front will reach there, and it will try to suppress. So, we need to take a few remedies by which we can control the speed of the main flame front, and so that we can prevent the detonation or knocking. So, I hope you have understood what is meaning by detonation or knocking. So, that means the collision between these two flame front will give an audible noise, and that is very detrimental for the operation of internal combustion engine. Entire combustion will be erratic, the pressure rise because of the combustion, that will be highly erratic. The engine, the operator can really understand what is happening inside the engine cylinder, and that is really detrimental. So, we need to take in this context, I would like to say that we need to take sufficient preventive measures so that this undesirable phenomenon can be prevented. Now, when the main flame front is propagating, this is the propagation of the main flame front will will act as a piston to the secondary flame. So, the main flame front is propagating and it is now travelling towards the secondary flame. So, it will now try to create, as if it is now the main flame front is now acting as a piston and it will try to pressurize the secondary flame. So, the pressurized secondary flame, that this pressurized may also enhance the combustion which is there in the zone very close to the secondary flame. If this is the case, then secondary flame will be propagated very fast because of the fast combustion, and that will try to enhance the detonation and knocking. So, we should consider, we should take a few preventive measures so that the propagation, the development of secondary flames can be suppressed. Although we cannot completely suppress the development of the secondary flames, but at least what we can do, that we can arrest the movement of the secondary flame. We cannot arrest the movement of the secondary flame at all, but what we can do, we can control the movement of the main flame. We can accelerate the movement of the main flame so that the secondary flame can be suppressed. So, I am not going to, I am writing a little bit more so that it will help you to at a later time to understand what we have discussed. So, what we can say, that the pre-ignition may rather will increase the pressure in such a way that the peak pressure advances, and sometimes the peak pressure may occur even before piston reaches at TDC during compression stroke. Right? The rise in peak pressure will oppose the piston movement thus decreasing the total power output. I will discuss in detail. So, we have understood detonation and knocking. So, because of the detonation and knocking, we have seen that pressure will be high, and the pressure, because of this pre-ignition, pressure will increase, and that will allow the peak pressure to occur when piston even when piston reaches, it will allow even when piston it will allow peak pressure to occur even before piston reaches at TDC during compression stroke, and the rise in peak pressure will try to oppose the piston movement, because piston has not reached at TDC at all. By that time peak pressure developed, and that peak pressure developed will try to oppose the piston movement towards the TDC, and for that eventually it will try to reduce the power output. That means if the peak pressure occurs before piston reaches at TDC during compression stroke, so to overcome that friction, to overcome the resistance because of this high pressure, we need to borrow more energy from the flywheel. So that will eventually reduce the power output or efficiency of the engines of the internal combustion engine. So we have understood that this pre-ignition is responsible for the another important undesirable phenomenon that is known as detonation and knocking, and not only that, because of this pre-ignition, peak pressure might will increase, and it may so happen that peak pressure occurs before piston reaches at TDC during power stroke, and the overall effect will be the reduction in the engine efficiency or total power output. So these two important points we should keep in mind, and now at least we should know what are the different points, at least we should take into account to prevent this detonation and knocking, so that the peak pressure rise can be controlled, essentially to to increase the total power output from the engine cylinder. And we also will discuss that what are the different factors can be considered so that the movement of the main flame front, speed of the main flame front can be accelerated, can be increased, so that the rise, rather I can say propagation of the secondary flame can be suppressed, and in doing so you can control the detonation and knocking in the process. So the rise in peak, the effect of rise in peak pressure in the context of engine operation, we have seen today that peak pressure might occur before piston reaches at TDC during compression stroke, together with the factors which are responsible to control the, rather which can be considered to control the main flame front, the speed of the main flame front, essentially to prevent the detonation and knocking, we will be discussing in the next class. So with this I stop here, I stop my discussion today, and we will continue my discussion in the next class. Thank you.